Hello guys, so today we're gonna be solving the fourth problem of this year's Polish mathematical Olympiad. So we're supposed to find all values of n for which one can arrange rectangles 1 by n, 2 by n up to n by n into a square, with a caveat that, well, those rectangles can be rotated but must not overlap, so we cannot put one rectangle onto another. Well, absolutely never. We can never do this. Okay, so what is the approach one can take when trying to solve this kind of a problem? Well, I think the best one is to just go on and try some base cases, just try some small numbers first to just get the sense of how the hell this problem works. And so, well, a spoiler alert here, the case of n equal to 7 is going to work, and I would like to visualize the problem to you guys on that case. So I have a grid right there, which I prepared earlier, and I have 7 rectangles. So 7 by 7, 6 by 7, and so on up to the 1 by 7 case. And we'd like to arrange this into a square. So how do we do this? Well, first of all, we would like to take the largest, the 7 by 7 square, and put it in the up left corner. Now I would like to take the 4 by 7 square and take it right over here, and then the 3 by 7 square and take it to the rightmost part of this group, let's say. Yeah, and now I would like to take the 7 by 6 rectangle, put it to the left bottom corner, then the 5 by 7, and then the remaining 2 by 7 and the 1 by 7. Unfortunately, as you can see, I have got a little bit of a problem here with the 3 by 7 guy, because I drew it, well, not quite perfectly, but nobody really cares about it. It does not change the problem at all. Yeah, so this is the grid after, well, creating a square out of all of those rectangles. Well, what do we see here? Well, you see that the sum of the lengths of the shorter sides in both of those, let's say, building blocks of a square is 14. Yeah, 6 plus 5 plus 2 plus 1 is 14. Well, 7 plus 4 plus 3 is 14 right over there. And also we see that, well, this guy right there has the, let's say, height equal to 7, so the longer side equal to 7, and this guy, well, just as well has the longest side equal to 7. Well, actually each and every one of those rectangles will have the longest side equal to 7, and so we have that this side right there is also equal to 14. Okay, so we have a square which is 14 by 14, let's say, unit squares. Okay, well, what does that tell us? I mean, what do we see here? Well, this for sure will mean that whenever we would like to get this kind of an n in which we will be able to make a square out of those rectangles, we have to be able to divide our rectangles we got, so the rectangles 1 by n and up to the rectangle n by n, into k groups for some kind of a k, such that the total area of those rectangles of rectangles in that group is gonna be equal to k multiplied by n squared. And, well, why is that so? Because, well, if we have an area of kn right there, yeah, and let's say n here, and we have the length of kn here on the longer side and n here on the shorter side, what we will have when we have k of those groups is that we will be able to stack those onto each other, getting, well, k multiplied by n those rows, let's say. So we have k by n here and k by n, k times n and k times n here, getting a triangle of the side of k multiplied, k squared multiplied by n squared. And so what we will get is that we have k groups with the total area of kn squared in each group. Well, is this necessary for us to get what we want? Well, just for the sake of, let's say, practice, or for the sake of being, let's say it, not restrictive, whatever, for the consistency's sake, we'll create ourselves, we'll assume that there will be an n such that we will be able to create a k times n plus some kind of an a by k times n plus some of an a square from the rectangles 1 by n up to n by n. Well, what is the area of such a square? Well, that's gonna be the kn plus a squared. Well, a is not equal to n, by the way. So what we'll get is from kn plus a squared, that's gonna be equal to k squared multiplied by n squared plus double kan plus the a squared. And guess what? This thing right there, this is not divisible by not divisible by 2. It's not divisible by n. And why is it so bad that it's not divisible by n? Well, each and every one of those rectangles right there has at least one side which is equal to n, and so its area just has to be divisible by n. Well, what does it mean? It means that if we sum up only rectangles with an area divisible by 10, then the sum we get after summing those up is just bounded. It has to be divisible by n. And so this rectangle right there was absolutely not achieved by combining n by something rectangles whatsoever. So we do not care about this case. We just, well, we proved it is impossible, so we don't debate them anymore. Lovely. Now, we know that we have k groups with the total, oh, I forgot to put an h here. So we have k groups with the total area of k multiplied by n squared in each group. Awesome. So, well, it's nice because now we can go on and, well, actually calculate the entire area of this beautiful square, which is going to be equal to, well, k squared times n squared. With k groups, each and every one of those has an area of k times n squared. Lovely. So that's the area. This is our area. However, there's one more way to calculate the area, and that is to sum up the area of each and every one of those rectangles separately. What are the areas of those rectangles? So the area as well is going to be equal to the area of the first rectangle, so the 1 by n rectangle, that's 1 multiplied by n, then the 2 by n, which area is 2 multiplied by n, then the 3 multiplied by n, and then we're just going to be adding those areas up until we get to the n by n square, which will have the area of n squared. And, well, the nice thing is that we can actually go on and take and factor n out of this summation, getting n multiplied by the sum from 1 up to n. And this is, ladies and gentlemen, actually a pretty nice arithmetic progression, which we, well, know the formula for. I mean, we probably had it in high school. If you're not in high school yet, then I have a proof of this somewhere on my channel in the previous, those bad looking videos. So yeah, it's somewhere out there. I'm absolutely sure about that. Lovely. So what's the sum of this thing? Well, this is gonna be equal, as I said, I have it somewhere on my channel, n multiplied by n plus 1 all over 2, and so that's equal to n squared, so that's equal to n squared multiplied by n plus 1 all over 2. Well, that's really, like, awesome, because we have two possibilities. I mean, we have two equations for the area. If both of those are equal to area, so both k squared, n squared, and also n squared, n plus 1 all over 2, those are both equal to area, then those are equal to each other. So we know that k is not a k. So k squared, yeah, this is not a k either, but I really hope you get used to the way I write k, which is going to be equal to n squared plus n plus 1 all over 2 right there. And that's awesome, because now what we can do is we can just go on and calculate n in terms of k. We can go on and cancel out those n squares because we don't really need them, getting that n is going to be equal to double k squared minus 1 for every single k. Whoa. boom. And this is our beautiful solution. Because see, for example, oh no, what did I do? I turned off my iPad. Okay, sorry guys. So, well, for example, 7. What is 7? It is equal to, well, let me just find it because I actually forgot. Is equal for double 2 squared minus 1. Huh? For k is equal to 2. So this will actually work for every single k, because when we just plug some kind of a number here, here for the k, yeah, here for the k, we will get an n such that there will be a k, because we actually derived the n from k in the first place, such that we will be able to achieve the state where we have k groups. Each and every one of those has an area of k multiplied by n squared, and so we're able to stack those k groups onto each other, creating a k by n square. And so this is the beautiful result we were after today. So n is equal to 2 times k squared minus 1 for all k's that are natural numbers. And I'm really excited. Hope you enjoyed it, and see you next one.